sure to record today. Okay. So what did we do last week? Last week we talked about while loops, which was our first control structure that we had for repeating something. And specifically, we need while loops when we need to repeat something for an unknown number of times, like verifying someone's password or sort of rolling a dice until a 6 is rolled. We cannot predict the number of iterations required beforehand in either of those cases. And then after that, I said, okay, we're normally not going to be using a while loop. A while loop is really only going to be utilized when we want to write sort of a REPL interaction with the user. And then I said, typically, we're going to be using for loops. But before I can show you how to use a for loop, I had to introduce to you all of the enumerable types. And those enumerable types, some of them were mutable. So we also discussed some mutable types last week, the list and the dictionary. A list is a lot like a tuple, but you can change it. And a dictionary is a lot like a list, except instead of having things living at numbered indexes, you can sort of have named indexes, which were called keys. So today we're going to learn how to utilize the for loop, which is yet another way of repeating code. But I think this is one of Python's best language features, in my opinion. And let's go through it. Okay, so a loop is a control structure that repeats code that belongs to it. So the most basic one last week was while true, just repeat something. And remember that we have to utilize space in order to indicate belonging. A for loop is a control structure that you give it a group or something that's enumerable, and it's going to repeat code for every member of that group in order. That's a little bit different than a while loop. So here's the sort of general structure of a for loop. So you say for, which is a keyword, then you give it some variable name, anything you want. That's, of course, legally named. And then you say in, and then you give the for loop an iterator, and then it's going to loop through this code. And we'll have a bunch of examples. To iterate through something is to sort of walk through it. And to be iterable sort of means that you can be put in order. So like the counting numbers are iterable, 0, then 1, then 2. The members of a string are iterable, like the first letter, the second letter, the third letter. But not all sets are going to be iterable. Like floats aren't iterable. You can't, like what comes after 0.00? What's the next number after that, right? So we have countable sets and uncountable sets. So the only thing we're going to be able to walk through are countable sets. Okay, string iteration. So this is going to allow us to access the individual characters of a string one by one. And I'll just remind everyone, we don't really have characters in Python. So when I say character, just interpret that as string of length 1 in Python. So a for loop will iterate through a string's characters. Right? That's why I put quotes around characters, because we really don't have them. So you can do something like for x in A, B, C, D, and then Python is going to repeat the body of the code, which is comprehensively at line 2, once for every character in that loop. And moreover, not only is it going to repeat something, this x is going to assume the value of each of these characters in turn. So for example, we're going to get A, B, C, D out of this. Right. So what happened is that, well, I have a Python visualizer that we can look at after this. So notice the order, right? We are going from left to right. So if the iterator that you have has an order, you're going to be traversing it in the same order. And also note that this variable here that you used as an iterating variable maintains its value when the loop exits, which is sort of important sometimes. Okay, let's take a look at the Python visualizer, which is here. So that's that exact piece of code that we just, That's the exact piece of code that I had written on the slide. So let's just see what the Python tutor is going to illustrate regarding this. Just a little bit different. Since we're printing, it has this sort of box here where it's going to print all of the output. So I'm going to hit next, and it's going to say, oh, I saw a for loop, and I want to iterate a name x through it. So I should have a variable name called x. And the first value that it's going to assume is the first sort of character in the string A. Then it will print that A, and then it will go back up. And then it's going to say X gets B, and then it will print B, and then go back up, and then X gets C, and then it will print C, and then X will get D, and then it will print D, and it'll go up to the for loop and say, what's the next thing? For loop's going to say the iterator has exhausted. Python goes, no problem, nothing left to do. I will exit this for loop, but note that there is still a value in X, right? X was sort of a new name that was sort of sneakily declared in the body of a for loop, okay? So it is also important that X will maintain this, right? So this is what's happening. We're just sort of doing a finite many number of repetitions on a piece of code, once for each member of some type of enumerable type. And we're going to do tons and tons of examples today. The whole third part of this lecture is only examples. Okay, so that's not sort of very challenging. What can become challenging is when we take loops and we put other loops inside those loops, right? Embedding these types of structures. So I'm going to define two sort of strings here: digits 0, 1, and 2, and alphas x and y, right? So sort of digits and alpha numeric characters. I'm going to have two loops here. I'm going to say for d in digits and for a in alphas, print d plus a. Now, the thing that you have to note here is that the loop is always repeating the body, right? So this loop is always going to repeat everything in here, right? So that is to say the interior for loop is going to be repeated many times. And then this will also repeat something. It's going to repeat that. Now, it's important how these things get exhausted, right? That is to say which for loop is going to finish first and which one's going to get repeated. But sort of since this outside one is controlling everything in here, let's just walk through what Python is doing. It's going to say, I need to walk this variable d through that string. So the first d that it gets assigned is 0. And then it walks into the loop and it says, okay, I need to sort of execute this code with d is equal to 0. And what does this code say? Oh, I need to do stuff. So I need to repeat code. So it says, I'm going to walk a through x and y. The first thing that a becomes is x. So what's the first thing that prints here? 0x. Okay, what's the next thing that prints? 0y. Whoops, 0y, right? Because this had to exhaust first. So this says, repeat the body of the code. For d is equal to 0. And this says, I am a loop, though. So I'm going to repeat something twice. And then d goes to the next character in the sequence 1. And then this for loop repeats itself again. It's sort of like it's reset itself, right? So this is why we're going to have 6 outputs here. We have we repeat something 3 times that repeats twice. So therefore, we're going to have 6 many things happen in that instance. So let's check out the Python visualizer for this. Python 2. So there's the embedded for loop structure, and we'll see how Python is sort of going through this. So at first, it just loads 2 of these names into memory, digits and alphas. So there we have our digits, and there we have our alphas. Now it's going to sort of declare a name d and set it equal to 0. There we have that. And now that's going to it's going to declare a name a and set that equal to x here. Great. And then it's going to print 0 plus x. That's how that comes there. But you see how that red arrow went back to that for loop. And now it says, oh, d gets y. Now go back up. And it says, okay, what should a be now? And it says, well, no, I'm exhausted. This for loop is finished. So it says, oh, you're finished? No problem. I will then go back to the original loop and then execute the next iteration of this loop. So d says, I was at 0. The next thing is 1. And it's then going to repeat the interior of this loop and then go back to here and set d is equal to 2 and then do the interior of this loop. And then d is going to say, okay, what's next? And the for loop's going to say, we're finished. So it says, okay, nothing more to repeat. I exit. All right, so we're done. All right. I'm now going to sort of move this print statement about. Right, so previous to that, the print statement was in interior of all of the loops. Now I'm going to move it one back. The reason that I have to put this pass statement in here is since Python requires spacing to indicate belonging, you're not allowed to have an empty for loop. So pass is effectively the null instruction. You may see it in some of your homework, but it just basically says it's the Python instruction for doing absolutely nothing. And we utilize it here because otherwise this would have thrown an error. My question here is, I moved the print statement out of a loop. So what is the first thing that prints in this instance? Well, we just have to walk through it, right? Okay, so digits gets assigned 0, 1, and 2. Alphas gets assigned x and y. So d has to walk through 0, 1, and 2, and the first thing that it gets assigned is 0. Okay, so D is 0. Then we enter the body of this loop and we say execute, and Python says, oh, I see a loop. I have to take A in X and Y. So it says A gets assigned X and then pass. And then A gets assigned Y and then pass. And then this loop finishes and we get to here. So what is the values of D and A in this now? What are we holding here? Well, D was what? It's 0. And what is A? Y. Right? So we're going to get 0Y, 1Y, 2Y. Right? Okay, so let's look at the visualizer for this. All right, just put that print statement 1 back. So D is going to get assigned 0, and then A is going to get assigned X, and then A is going to get assigned Y, and then A is going to say, oh, we're finished the loop. But remember, the values of the looping variables maintain their value after the for loop is done. It doesn't sort of destroy that variable. It's still hanging around. You can see it in the table. And that's why at this point, we're going to print 0 and Y. And then this red arrow is going to go back up to 2 because it needs to go to the next iteration of the sort of outer for loop. D is going to get assigned 1. And then this for loop inside is just going to exhaust, but still hold a value Y afterwards. And we're going to print 1Y. And of course, just the same thing again, right? We're just same procedure. Right? So the objective, like the learning objective here was to know that that A is going to maintain its value once that loop finishes. It doesn't get destroyed. So one more. I'm going to move the print statement totally left. Is this print statement going to be repeated? So how many prints do we expect to see here? 1. And what are we going to print? Or tell me why we're confused. Because everything subsequent to here is going to be complications over this example. So if we don't have a concrete understanding of it, things were going to get hard. So either tell me what this prints or tell me why we don't know. Yes, miss? 2Y. Does everyone agree with that? Yeah, because this is totally outside of both loops. So the only way to arrive at line 5 is for the loop at line 2 to have exhausted itself. And for the loop at line 2 to exhaust itself, also the loop at line 3 has to exhaust itself. And when we leave those loops, D is going to still be holding its final iteration value, which is 2, and A is going to be holding its final value, which is Y. So we're going to print 2Y in here. So note again, the names used to iterate through the iterator retain their values after a for loop exists. And that's useful. This is very useful. Okay, so now we're just going to do some sort of practice with for loops, because I think that's really how we're going to learn how to utilize them properly. So recall an accumulator is a variable which a loop uses to accumulate a random, an aggregate value. So this is kind of silly. So I'm just going to say, let's accumulate on the empty string. And I'm going to say for X and A, B, C, D, just add to the end of this accumulator. So what's going to happen here? So X is going to be A. So accumulator is going to be empty set plus A. So accumulator becomes A. Then I print A. Then we go back up here. X moves to B. Accumulator is A is equal to A plus B. So accumulator becomes AB. Then we print AB and so on and so forth. So you get A, then AB, then ABC, then ABCD. So you see how we're like accumulating values? And this type of like pattern is very common, where we're just going to be running through a for loop and accumulating something. Now, what happens if I switch the order here? What is going to be the outcome now? What will we print? What's the first thing to print? Yes, sir. Empty set. Does anyone agree that the first string to be printed will be the empty string? I disagree. Anyone? What? Yes, miss? It will print A. Let's just walk through this, right? So accumulator gets assigned empty string. Then for X and A, B, C, D means X will get assigned A. Accumulator is going to get A plus empty string. So accumulator is equal to A at this point. Okay, that's not the interesting thing. What's the next thing to print? Yes. BA, right? Because we're accumulating from the other side now, right? Then CBA, then DBCA. right? So all I did was sort of switch these two things. So you can always like right accumulate or left accumulate, but it will make a difference, right? Just be careful because you're used to addition being commutative, right? A plus B is equal to B plus A, but it's not always it's not commutative for strings, right? Hello plus world is not the same thing as world plus hello. So it does matter which way that you add these things together. So just be careful. Can every for loop be rewritten with only while loops? If I like took away for loops from this class, would we still be able to do everything? I'm getting some thumbs up. Yeah, right. Because the a while loop allowed us to repeat something a potentially infinite amount of times, but that also provisioned us with a tool that can repeat something a finite number of times, right? So if you have a for loop like for x and x's, do something with x, I can have the equivalent for loop that just uses an iterator to walk through that. So I can say k is equal to 0, while k is less than the length of x's, do something with x's at index k, and then increment the index. Why do you suppose we want to do this and not this? This is like really error prone. You're going to screw up your indexes. It's twice the amount of code, right? So if you ever see yourself doing something like this, stop. If you really do need the index of a list item, I'm going to show you a way to get it. So we're always going to do something like this. You should never do this. But because I can rewrite this as this, we don't actually need this tool. And you should know that's what that's what the language actually does. It says, oh, we don't really have for loops. We really have this while loop. So every time the user writes a for loop, what's actually going to get written in machine instructions is the while loop. Converse question, can every while loop be rewritten with only for loops? Yeah. Yeah, like how can you get a for loop to repeat itself an infinite amount of times? Right. So, okay, but there's a cap. So no, consider how many times you need to repeat asking a user for correct input, right? Because I delineated these loops into two pieces. While loops, which are used if you don't know ahead of time how many times you have to repeat, and for loops, which are used when you do know how many times that you have to repeat. But there's a technical caveat here. In Python, it is technically possible to create an iterator, which you'll create in the objects part of this course, that never exhausts. Okay, so actually, professor, but like more technically, if you like actually look how Python has created that iterator, it uses a while loop. Okay, so I don't want to argue about this over the EdStem. Like philosophically speaking, we can't use a tool that can repeat something an finite number many times to simulate something that potentially repeats an infinite amount of times. Right, so that's what I designate between while and for. Although, like technically speaking, you can trick Python into doing it, but then we're going to get into a huge semantic argument. Okay, here's an exercise. Return the string with all instances of C removed from C. So I'm going to give you like a string like Bluey and a character like B, and I want you to remove those characters from that string. And I don't want you to solve this problem by going to Google and asking for the string method that this does this, because on your exam, I can always say, you use this method in your assessment. Implement it now. And I've done it before. So whenever you use a method or something that you find on the internet, you should first implement it yourself, right? Just in case we ever do ask you to do it, because I do believe there's a string method for remove, which we'll talk about in our string class. Okay, so I'll bring this in. Okay, so I want to define a function. I want to call it remove. Get away, head. Everyone can see this? Cool. And I want to do something like remove all instances of C from the, maybe one smaller, one bigger, from the string C's. So something like remove C from, was it chili? Was something like hilly, like remove, what else did I have? Little b from Bluey. With a capital, that's just going to return Bluey back. And one more usage case. Maybe, okay, remove, I don't know, I'll do X from XY, XY, X should be YY. Everyone get the problem statement? Okay, so this should not be very difficult. So what I want to do is just accumulate. and skip the ones I don't want to accumulate. So as I said last week, we don't code like first line, then second line, then third line, then fourth line. I'm just sort of going to fill this in as we go. So I know I need an accumulator. What am I accumulating here? Am I accumulating numbers? Am I accumulating lists? Yes, sir. I'm accumulating a string. So my follow-up question then, what should we start accumulating from? Empty string. Okay, so I'll put that there. And then eventually we're going to want to return this. This is going to be our answer. Okay, so, and already like I can just ensure that we haven't done anything wrong yet, right? That it works. Technically, there's no syntax errors in here because I want to compile a lot. I want to run a lot. Okay, so how are we supposed to do this? Well, if in order to remove a character from C's, I'm going to have to bare minimum look at all of the members of C's, the input string, right? So I can say something like, for a character X in this input string, it's going to look at each of these elements in turn, right? So I've pulled out a character from that input string. Now what should I do with it? Should I just well, let's just do this. I'll just say, oh, let's just accumulate on X and then see what this gives us. All right, so if I remove X from X, 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 Y, what do I expect this program to return as written? No, well, it's just going to return this. It's not working yet. It's partially working. Right, so I've just proven to you that I can, in fact, touch every member of C's and collect it. But like, what's the one extra thing that I have to do to solve this problem? Yeah, sure. Okay. But like, this concerns me. Like this silence. You have like three control structures: while loops, for loops, and if statements. The three tools. So does a while loop help us here? No, we're already looping. Should we use another for loop? No. So the only other control structure you have at your disposal is the if statement, the ability to make decisions. What decision should be made at this point? Well, yeah, whether we should keep X or not. Right? So what is the objective of this function? Is to remove all instances of C. So shouldn't I say something like, oh, if the character that I am looking at in C's is equal to C, the thing that I want to remove, then what should I do? Well, not accumulate. Well, let's just do the opposite. I just want to make sure that this is not the thing that I want to remove. And if it's not the thing that I want to remove, I'll include it. So let's see if this works. Here we go. Let's try to remove B from Bluey. Right, let's try to remove B's from all of these. Okay, let's try to remove something that's not there from there. Okay, so this is a fairly simple use case, right? We just use the for loop and an if statement. In some sense, this is like the simplest, like the first non-trivial example that we can have, right? Of one structure and another structure. Is there any questions? We're just going to do so many of these today until we're comfortable using these for loops. So is there any other questions regarding this? Okay, we'll just move on then. So there's the answer. Okay, list looping. So we've looped through strings, but the other thing that we have at our disposal are lists and dictionaries. So I'm going to show you how to for loop through each of them. So if you have a list, for looping through list effectively is the same thing as for looping through strings. Right, except that the list is sort of a reference to that list, so funky things can happen if you're changing that list while you're looping through it. But let's not get too bogged down with that. So here's a list, X's. It's comprised of types of a character type and an integer type. So a character, then an integer, then a character, and an integer, which is not something that a string or a tuple could do. And it's just going to do the same thing. I'm going to say, oh, well, this is clearly an iterable. Like this is clearly like a list of things that we can walk through. So that's what this instruction says. For X being made, for X iterating through that list, what are we going to get? Well, it's just going to say X gets first A, and then I'm going to print A. Then X gets 2, then I'm going to print 2, and so on and so forth. And again, what is the value of X when we finish this loop? Yes. E. It's always going to hold on to the very last value that it iterated from. Okay, so here's another one. Make unique. Okay, return the unique elements of a list X. Let's try doing this one. I wish my slides were more copyable. Okay. Okay, so you give me a list of numbers, and I'm going to return to you a new list of numbers that are comprised only like of the same elements, but none of them repeat, right? So 1, 2, 3, 4, those are all unique. So you just get spit back 1, 2, 3, 4. Here's a list with duplicates. So there's 1, 2, 2, 2, 3, 1/4, -3. So here's a list of its unique elements after that. So how can we do this one? Any ideas? So bare minimum, what do we have to do in order to solve this problem?
Equal to 0 so that the computer doesn't think that there's numbers before that. Yeah. You know, it's the same thing with strings as well, you know. You first equals to 0 so that the computer doesn't think that it starts from any integer, right?
I'm not sure what you're saying. Like what the answer I'm looking for here is we're bare minimum going to have to look at each element of this list. Would you agree with that?
Yeah. We need it to be empty at first.
Oh, you're talking about the accumulator. Yeah, I understand what you're saying. Okay, so my colleague over there is saying, like the previous example, where we accumulated on a string, where we did something like this. What's the answer going to be in this case? You can read it right off the type annotation. What's the answer going to be? A list of integers, okay? So what should we start accumulating from? Empty list, not empty string, right? Because I eventually want to return a list. I want to build that list, and you got to start building that list from the empty list. If you want to build a string, you got to start building that string from the empty string. Now, the other thing that I was getting to is if the bare minimum in this bare minimum, we're going to have to look at every member of x's, will we not? So I have to say something like 4x in x's, right? Because I need to say, are you a duplicate or not? And if you're not a duplicate, then you get to go to the answer. So how can I check what is the logic here? Yes, sir. Yeah. So look at every element of x's. Ask, hey, is this already in the answer? If it's not, then put it in. Then it's not a duplicate. If it is already in the answer, then don't do anything with it. Like maybe it would be more clear if I said this. Okay, so if x is in the accumulator, like do nothing, right? Else add x to the accumulator. Okay. It's going to complain. I need to do pass. But like, why don't we do this? Yeah. It's exceedingly bad style. You should never have an empty branch of a for loop. This is one of the explicit refactors that we talked about last week. I never want to see this because you just put a not in front of here. You can delete the empty branch. Right? So there you go. Right? You don't always have to have an if-else statement. Is this going to work? Well, let's check. Make unique. It's so quiet today. 1, 2, 3, 4, -3. Let's see if we can make unique a number of unique numbers. 4. Okay, so what about a bunch of numbers like this? Cool. What about this? What would we expect make unique to return on the empty list? Error? Yeah. I would expect it to return the empty list back. Right? I'm saying here's a collection of no elements. Remove all duplicates. And I say, here's your empty collection back. I removed all duplicates. Now my question is, does this actually account for the empty list? Will this work? Okay, well, let's first see. Aha, it works. But what happened? I said, if we walk into this function, I'm saying, okay, I'll give you the empty list. And then the function says, okay, I'll start an accumulator at empty. How many times does this for loop execute if I say 4x in empty list? 0 times. There's like nothing in the for loop to do. So if I say like 4x in empty list, print x or print 1, nothing is going to happen. right? There's nothing to walk through. Okay, so this for loop therefore never ran, and so everything got skipped, and we just returned the empty list, right? So this did work for the empty list. Cool. Oh, that's for list comprehension. Ranges. Okay, so sometimes you do want to work with like lists of numbers for a variety of reasons. And we have a rapid way of building these in Python. Now, this is going to be a little bit strange because Python is what's called to be a lazy evaluative system, not an eager evaluative system. And there's like benefits to that. So what that means is that it doesn't compute something unless it absolutely needs to. So we often need to work with ranges of numbers. So like suppose you want to work with the numbers 1 through 1,000,000. Or we could do something like this. I sort of said it, I want to say 4x in 1, 2, 3, 4, 5, print x, something like that. Let's just run it. Okay. But like, suppose I wanted to make this way bigger. Suppose I wanted to make this like 50 million. I don't want to store the first 50 million numbers in memory. That is unwise. So what we have in Python instead is something called range, which effectively does the same thing. But if you look at what range is, it just says I'm a range from 0 to 5. And the weird thing about this is that it's an iterator. I believe I can do this. Oh, no, not yet. Hold on. Forget the syntax. Right? So it's created a list that doesn't sort of exist, right? This is much more memory efficient, but it's just a little bit weird when you say I need a range. Like I can say 4 now x in range, like a big, and it will do it, but it's not actually holding a list of like the first 500,000 or million numbers or something like that. But this is weird that it doesn't print out like a list. And it says that I'm just a range. I'm waiting to be evaluated. If you want to see what's in a range, you can convert it to a list, but that's not very advisable if this is like quite big. See, it's struggling. This is struggling. My computer is going, oh God, I have to load a lot of stuff into memory. So it's not going to work, right? Whereas if I do this, oh boy. Yeah, okay. I have to kill this. I really borked this. Where are you? Is it this? Did it finish? I think I think it just crashed out. Okay, we're fine. Okay, so going through these, well, my point would be like I could create a really big range like instantly, right? Whereas if you tried to do the same thing with a list with numbers in it, it would be basically impossible. You'd fill up your memory. So it's like this is a very deliberately made object. It's just sort of weird because it's set up to be delayed. But this is how our for loops work. You pass it something like this, which is an iterable, which just has one thing that it could call that says next. So your for loop keeps going next, next, next until it hits the end. But if you want to range 10, it's just going to say this, which may not be satisfying. If you ask for the type of a range, it's just going to say you're a range. If you want to see what that range is, you can always convert it to a list, but not advisable. Only convert to a list for like debugging purposes or for like trying to understand how this works. Now, the ranges work effectively exactly the same as the list slicing works. So to get a range, the range from 2 to 7 is going to be a range that starts at 2 and ends at 6. Because the right endpoint is always going to be excluded, right? For all of our list slicing, it was always left inclusive, right exclusive. So this is going to go 2, 3, 4, 5, 6. This is going to go from 2 inclusive, 7 exclusive, but go by 3. So 2, then 5, and 8 not included. So 2 and 5. This one is going to say, can you go from 2 to 7 walking backwards? The answer is no. Can you go from 7 to 2 walking backwards? The answer is yes. Okay, so effectively, it's exactly the same thing as list slicing. So you don't actually have to really learn anything new here. So range can be used to walk through lists using an index, right? But again, don't do this, right? So we have x's is 11, 22, 33, 44. I can say 4k in range length of x's. Do something with the list index x's of k's. And you see, because we didn't have to adjust this, like range is set up to facilitate basically exactly this computation, because we know we can go from 0 to length -1 in a list, right? So this prevents us from having to put the -1 there. It says, oh, no, we know that we're usually using these ranges to sort of walk through something. And since we're a zero indexed language, we should exclude the very last, the length, right? So this was sort of a wise decision. Now, I don't want to ever do this, right? Because it's much more preferable to just say 4x in x's. Do something with the x, not for some list index that goes from 0 to length -1, then take x's at k out. This is a very C or Java style way of doing this. We're in Python. These for loops are the best language feature in my opinion, so we should definitely use them. There may be instances where you're like absolutely required to know the index of a item that you're utilizing. Like suppose I want a frequency table, or I want a table that tells me where all of the x's, the indexes of all of the x's can be found in the string. I think we have that as an example. You would need the index in that case, but this is the function that you want to utilize if you want both the index of something in the list and the list element in itself for some odd reason. It's called enumerate. You can basically regard it as doing this, although it generates an iterator, so it's a little bit more tricky than this. But you give enumerate a list, and then enumerate's going to return back to you a list of tuples, where the tuple is the index and then the value. Right. So I'll show you maybe here on a. Okay, so we have Drake is overrated. Okay, and then enumerate this. Enumerate x's. So it's going to say, this is weird, right? Because it's this one of these iterators. It didn't actually build anything. It's just waiting to be walked through. But I can always convert this to a list, and then you can see what it's holding. It's saying, oh, okay, at index 0 is D, at index 1 is R. And then the great thing about this is that you can say, oh, okay, so I have an index and the value of x in enumerate x's. And I can say something like, okay, let's just print something formatted. I can say x's at k is equal to x. Let's see if that works. Oops. Let me try that again. That should have brackets around it. Okay. So use enumerate if you ever want to get the values of something and the index of something, right? Because I don't have to increment anything here. That's sort of the thing that we're trying to avoid, right? Index errors are very common in programming and very hard to debug. Okay, so again, if you want index and value, use this enumerate function. What is the outcome of this going to be? So for kx and enumerate scientia ac labore, if I print kx, you're going to get 0 science, 1 ac, 2 labore. And by the way, this is UQ's motto. I don't know if you were aware of that. And it literally translates to by means of knowledge and hard work. This is how you develop a skill set here. Okay. The last item that I want to, or object that I want to be able to loop through is a dictionary. Now, what did we learn dictionaries were last week? Well, these were unordered collections of items. And these items were key value pairings, right? So I could say something like, I have a dictionary. I want to map sort of Paul to the value 1. I could also map the value 100 to the last name Verbic, right? So it's this weird sort of structure which allows us to do list indexes by arbitrary types of things, right? So it's a list where the indexes aren't necessarily just numbers. They're numbers in anything that you want. And there's a hash function that facilitates this, but Python basically hides this all away. Okay, so the question is, how then can I process dictionaries? And the answer is, you just for loop through them the same way that you for loop through tuples and strings and lists. But when you do this, what you're going to be for looping through are the keys of the table. Okay, so strings were for looped character by character. Lists were for looped element by element. Dictionaries are going to be for looped key by key. Right, so a very typical for loop would be something like for this key in the table, the value is equal to the table at that key, right? This is Python code that would work. That's grabbing the keys and the values, right? So here's a dictionary that maps red to 1, blue to 2, green to 3. And I can just say for key in H, print the key. It's going to print red, then print blue, and then print green. H is a red goes to 1, blue goes to 2, green goes to 3. For key in H, I can print H at key, and then here we're going to see all of the values, right? So the only thing that you have to remember is when you for loop through a dictionary, the dictionary is going to, you're going to be extracting keys from that dictionary. Okay, so we had this problem that actually motivated introducing dictionaries, and that was, oh, can you tell me what the character frequency is of a string if I were to give you a string? And like the learning objective there was to realize, oh, we have to actually think about how we're even going to encode the solution to this problem. It's not just that of computing it. And then we arrived at dictionaries as the new data structure required to actually codify the answer to this. So now let's just create it. Let me pull this in. Okay, return a dictionary mapping the characters or length one substrings of x's to their number of occurrences in x. Okay, so, oops, these are the wrong. They don't like that. Let me just replace these. Those are the special latex quotations. Okay, so a little a, big A, B, B. So in here are two small a's, one capital A, two small lowercase b's, and one uppercase b. And that's all sort of been encoded into this dictionary that maps sort of those values to their frequency. So the question is, can we code this up? Okay, so the input is going to be a string, and the output is going to be a dictionary, which has characters as keys. We don't really have characters. That's why I have to put a string here. And then maps those length one strings to their frequency. So the question is, what do we do here? And it's effectively the same pattern as the two previous examples that we did. We need to accumulate a dictionary now. So what is the empty dictionary? Well, I'll just say that's the empty dictionary. This is also another way to get an empty dictionary. I think technically this is a little faster if I can remember, so I'll do that. So I'll just say though equal to also works. Okay. And then I want to return that dictionary D. Okay, so what do I do now? I'm just thinking of things I have to do. Like if I have to create a character frequency of the input string x's, what am I obligated to do with x's? I've asked the same question 3 times now. Yeah. Like if I'm generating a character frequency of the characters in x's, bare minimum, you're going to have to look at each one of those characters. Yeah. So I'm going to say for x in x's. Okay. I'm going to look at every character of the input. Okay, now what do I do? Yes, sir.
Then D with X with the next one, D with X, yeah. And then also else. And then else D with the X.
Perfect. Okay. So what we have to do, okay, so I grab one character out of x's, and I'm building this frequency dictionary. So what do I have to do? I have to say, oh, okay, here's my x. Is x currently in the dictionary as a key? And if the answer is yes, then it's great. So then go and increment that count by 1. We've counted at least one A, so now I want you to increment that A by 1. Otherwise, what happens if it's the first time I encounter a number? The first time I encounter a number, there's not going to be anything in the dictionary. So if this wasn't here, okay, if I were to take this out, then this would immediately throw a key error. Because this assumes, right, it's saying go get the thing that is mapped from X in D and increment it by 1. Right? That is different than this statement here that says, oh, put a key X into the dictionary. Right? This one can't error. This one can error. So this one will error if the key doesn't exist. So if X is in D, that is to say, if X is already a key of D, then previous X's have been counted. Increment that count. else this is the first encounter of X. So add it to the dictionary and count it once. Okay, so let's see if this will work. Character frequency. Oops, I need to. Character frequency of this. Cool. Does anyone have any questions regarding that? Do you want to trace this a bit, or it's hard to gauge the class today? Yes, sir.
Can be also all of the letters.
All of the letters. Look, there's capital A.
So it's a coincidence that you put for capital letters one and smaller letters two there.
Well, A only occurs once in this, right?
Yeah.
So if I did that, then that would be this.
But they have different values.
Yes, that's why I'm not sure. Like capital A occurs 3 times, and small lowercase a occurs twice.
Also, the address 0x doesn't impact it, right?
I'm not sure what you mean by 0x. Yeah.
The addresses for integers always starts with 0x.
Well, this isn't an add. This is anything. Any object that's immutable can go there. That's not a number. Well, it's not necessarily a number. It is any immutable type because we're keying into a dictionary. This is not a list. It's a dictionary. It's a little bit different, right? So if I were to show you what these X's are, whoops, right? We're going through those, right? It's the letters. It's not numbers. It's not numbers. Okay, cool. Okay, there's the answer for that. Okay, so for loops enable us to iterate through anything iterable. Strictly speaking, they're not necessary. To repeat something k times, we could just copy paste k times, right? Or use a while loop. But we use it so much that it merits their introduction. So do use for loops. They're like Python's nicest language feature by far. But there's one extra thing that I want to do with for loops that we normally don't do. But like, I think this is so important, such an important part of Python's feature set that I'm going to show it to you. When I was working at the University of Toronto, we introduced this to our first year students, and it's going to help you with your code. It's going to make your code a lot more compact. Okay, so I want to show you list comprehensions. And some of you may have already seen these in your math classes, called something maybe like set builder notation. So who's seen something like the top there? Did I actually? Yeah. Have you guys ever seen stuff like this? You should, like in your math classes. So this is a way of constructing a set, right? Say, oh, this is the set k squared such that k is drawn from that set. So I could rapidly say, 0, 1, 4, 9. You could also say things like, oh, sum k over that set and of k squared. It'll be 0 squared plus 1 squared plus 2 squared plus t squared. So we have actually provisions for doing this in Python like this, right? So I can say k squared for k in range 4, and I can say sum k squared for k in range 4, right? So it's a way to actually avoid doing accumulation, or not. This is like a notation for doing accumulation in one line. Because suppose I wanted to build the list of the first 4 squares. I would have to do it like this. Okay, so here's an answer. I want the first 4k squares, so I'm going to go like this. And to answer, I want to append k squared, something like that. Let's just print answer. Okay, I'm saying there is a shortcut for doing this where I can say just accumulate in a list k squared 4k in range 4, and it will do it in one line. Okay, and the fact that we can very rapidly build, because we do this a lot. I've shown you like at least 3 examples where the only thing that we did was accumulate, and we're going to get a lot of leverage out of doing stuff like this. So for example, like there's a string method for counting stuff, which means that I can write a dictionary. So I can say X goes to count x dot count for x in Drake is overrated. Whoops. I shouldn't try this. Hold on. Something is wrong. Okay, let me get back to that when I have the real. Okay, this is very confusing. Hold on. That should work. A goes to a dot count a. So I should never light code. That should have worked. Let me try one more time. What is wrong with this? Let's try some debugging. So I'll just do this. That should give me every letter. Yeah, no problem. That should give me keys. Yeah. So I should be able to say, oh, I'm doing this wrong. Oh, I'm a lunatic. Sorry. There's the string. And then I want to build the frequency dictionary like this. I can say, I want x goes to y's that count, x for x and y's. There's your frequency dictionary in one line, rather than having to build that whole like accumulator. Okay. So that's sort of like it used to be a lecture in this class called functional programming. I teach the functional programming class. That's a year 3 class where all of our code is one line, right? Because we're really leaning into these list comprehension stuff. So these are exceedingly useful. So that's why I want to show it to you now, so we can like exploit them for the remainder of the year. So here's I showed you a list comprehension. Here's a dictionary comprehension, the one I sort of just flubbed. But again, I can say, oh, x gets keyed to that value for these x's, right? So you sort of get 0 goes to value is 0, 1 goes to value is 1, 2 goes to value is 2. X goes to 0 for x in ABC. This is really useful for like, if you want to load a dictionary with default values. It's like one of the options for our dictionary frequency, rather than checking if the key exists before, would have just been to say, hey, for every letter of this input string, map it to 0 as its default value. And you could rapidly do that with a dictionary comprehension, which is great. So if I have C's as hello world, X is the key, maps to C's dot count X for X's and C's, generates that frequency dictionary in one line. Right? So you can really make your code a lot more compact by, like, every time you see an accumulation of something, you can replace that accumulation with a list comprehension. You can nest these comprehensions, right? So you can have sort of more than one for in a list comprehension, and it's not just 2. It's 1 or 2 or as many that as you would like. You just have to keep you have to take care about which order these for loops are going to exhaust. Okay, so I'm saying for A in ABC and for X in range 2. So A is going to be A, B, and C, and X is going to be 0 and 1. Let's see how this evaluates just to figure out which one exhausted first. Okay, so you see here that it's A, then B, then B, then C, then C. This means that this for loop is allowed to exhaust, right, first, rather than that one. I have on the next page, I'll show you how to convert this to 2 for loops. If you reverse these 2 for loops, then you see we go A, B, C, not A, B, B, C, C, right? So the way to understand this is, if you have this list comprehension as your sort of accumulation, the way to write that as a embedded for loop is as follows, right? So if you have x's is equal to the tuple ax for A and ABC for X in range 2, this is the equivalent loop, right? So these for loops are sort of listed in order of their embedding. All right, so always the thing on the rightmost is going to exhaust many times, and the thing on the leftmost is going to exhaust only once, right? So you should always be able to pick off the way that these are enumerating by just imagining what equivalent embedded for loop that you would have. Okay, so let's do this one. Write a function which disassembles a string into a list of characters comprising the string, right? So you give me sort of a string, and I want a list, and that list should contain all of the individual members of that list. We're going to do it in two ways, okay? Old way and new way. Oh boy. Wasn't really worth taking. So it's something like disassemble Bluey should turn into B, L, U, E, Y. Okay, So here's the old way. I would say, okay, I need an accumulation. We need to accumulate a list because the thing that's being returned is a list type. I eventually need to return that list. And let's just accumulate. I'm just going to say for X and C's. Yep, just accumulate those X's. And that would work. Whoops. Already. I can say Bluey. And you get all of these characters individually like that. Now, this is the old way. Here's the new way. So I can just say return C or C and C's. Same thing, one line. And actually, like all of that decoration then sort of becomes like, I don't know. There are ways to define functions with one line using lambdas, but we're just going to skip it. But technically, we would never define a one-line function like this in Python. It's a little bit wasteful. Let's just get rid of this. Here. Okay, so there's the old way with the for loop, and here's the new way with the list comprehension. Write a function which checks if a string has strictly more capitals than lowercase letters, ignoring all other characters. How can we do this one? And then now, of course, it gets more fun because like I'm not really showing you more control structures. We're just actually coding, which is the thing I love doing. Any ideas here? Or like, what are the component pieces that we have to do? Yes, sir. Well, yeah, don't tell me, just give me a high level idea of what we should be trying to accomplish here. Okay, but like this begs the question, how do we determine if something's a capital or not a capital? Don't say a string method. I want to just do this using the tools that we have. Using only the tools that we have. Can we write a function that determines if something a capital or a lowercase letter? Yes, sir. You can use its order, sure. How? That's true. Getting closer? Yeah. So let's write two functions maybe. Is capital. C's is a string, and we'll return a bool if it is or not. So something like is capital A, that should be false, and is capital A should be true. And it could be something like return. So I just want to check. So when is C's a capital? Oh, there should be a precondition here too. Precondition. Length of C's is 1. Okay, so it's truly a character. Return what? Well, I just need to check if C's, which is the input character, is less than or equal to capital Z and bigger than equal to lowercase a. Right? Not everything has to be complicated. Okay, so let's see if that works. Whoops. Do I have an is capital function that works? A, true, that, false. Okay, so how should we define like lowercase letters? Same way? It's kind of weird because there's not really like a consistent definition of what is uppercase and what is lowercase. Because I would say, okay, like one way of defining is upper or is lowercase is that it's not a capital. But then something like the at symbol would be a capital or not. But okay, so I'm just going to do this. I'm going to say is lower. That has to switch. True. False. I should put those chevrons there. And I need to change this to an A and a Z. Okay, so we should now have is capital, oh, is lower working? False. Okay, cool. Boosh. Boosh. We'll just hide that away. Okay, so now I can check if something's a capital and I can check if something's a lowercase, right? And we're leaning into this abstraction. These were certainly two things that we were going to have to do when solving this problem. Okay, so now that I can determine if things are capitals or not, what's the next thing that we have to do? Yes, sir. I got to count the number of capitals and I got to count the number of not capitals. And then I got to like compare those. Okay, so two ways. One with comprehension and one with for loops. So here's a for loop way. Well, I need to look at every member of this. I need to look at every character. So I have to do something like this. For C in C's. Okay, this is the for loop is the thing that lets you look at every member of the iterable. And I need to have something like cap count low count. These both start at 0. Okay. And then afterwards, I need to return what? Provide, like, if cap count and low count have been faithfully assigned, what am I returning? More capitals, right? So how can I check if there are more capitals than lowercase letters? Yes, I just have to check if the capital count is bigger than the lowercase count. And yeah, maybe we'll assume strictness. I'll just put an extra usage example here. I will say this does not have more capitals, right? They're equal, right? So we'll just make it strict. Okay. So I'm in my for loop now. So now all that's required is if it is the case that this is a capital, then I want to increment my capital count by 1. Else, well, okay, that's technically, okay. If it is a lowercase, okay, then I want to increase the lowercase. I couldn't have, if I used an else in this situation, then that would have been counting everything that wasn't a capital as a lowercase character, which may not necessarily be what we want. Okay, so let's see if this works. Is it the case that there are more capitals in that? Is that true? How about this one? Great. Okay. Is there a one-line solution to this problem? How can I use comprehensions to help here? We have to be a little bit clever. Okay, so let's take a look at this string here. Whoops. What is happening? Oh, double quotes. Okay, there's a string. I'm going to make a list comprehension. I'm going to say, let's check if this is a capital for x and x's. How can I convert this to the number of capitals in x's? Yeah, that's good. Hey, remember this. What is 3 in this case? Is the number of capitals in x's, isn't it? Okay, so I said that we can actually sum over these things. And I can actually do that for this. So actually, all of that was kind of not necessary. I just need this. And I just need this. And then that's a working program as well. Whoops. Did I lie about it being? Oh, C's. I'll just change this to X's. Okay. I think it's pretty cool, right? So it's very compact, right? A statement like this, right? And we can exploit the fact that true and false have these sort of 0, 1 values. Okay, a useful hack to remember is that these integer values of true and false are 0 and 1. So if you can add them, you get 2. So there's like a one-line solution to that more capitals problem. Write a function that checks if every element of a list is truthy. And let's bypass the for loop. Well, maybe we'll do both again. Okay, so I'll do the for loop one, but then I definitely want a list comprehension version of that. So how can I go through a list and check if everything is truthy? Right? Does everyone understand the problem here? Like 1 is truthy, 2 is truthy, 3 is truthy, so everything is truthy. Here, A is truthy, empty string is not truthy, that's falsy, so we got a false here. And the empty list, we'll just say that that's always truthy for recursion reasons. Okay, any ideas? So let's just do this the normal way. How can I return this using a for loop? Yes. That's, yeah, good idea. I was going to use an accumulator, but my colleague over there sort of suggested something a little bit more to the point. So look at every member of the list. If it's not the case that X, what has happened? We found something in the list that's what? Falsy. Okay, so it's not true. Otherwise, what happens if we make it through this for loop? There was no instance of a false in this list. So here we know that every member of X is truthy. Otherwise, we would have exited with false. So therefore, return true. Okay, so let's check some of these examples. Oh, there's a mistake in my example. False. Okay, great. Can we do the list comprehension version of this now? How can we do this with list comprehensions? Any ideas? Yes, sir. Like last time, I'm going to take the sum. Yeah. X for X in X's. Okay. This has to be equal to the length of the list. Okay, so think about it this way. Look at this. Okay. There's a list, X's. I can convert this bool X for X in X's. Oh, I should convert that to a bool. Okay. True, true, true. If you sum that, what do you get? 3. What's the length of X's? 3. So the only way for a list to have only truthy values is that if you sum it, and like if you sum its truthiness, you should get the length of the list. Savvy? And if not, we'll take this list. We'll make this equal to X's. Here's the sort of Boolean version of that. And it's length 2, not length 3. So it isn't truthy. Okay, so we have a one-line solution for this. Let's check if that works. True. True. Oh, sorry. It's true that it's false. And let's see if the empty one works. Also true. Cool beans. All right. So there's that one. We can write a function that checks if any is an element of a list is truthy in the same way. You just have to check that this is greater than 0, right? So this is so we have one function all that checks if everything in a list is true. And we have another function any, which checks if something in a list is true. And the reason we're doing this is because any and all are prelude functions. You have access to these things already. Okay, hold on. I'll reset. Whoops. So this is Python. I don't have access to that all. And look, well, I'll just prove any. True, false. Right? It's in there, available to you, right? All also exists. Okay, and I'll show you why these are very useful. Okay, so here's a string, hello world, everything's in capital. How can I write a statement that says, check if X's is comprised only of capital letters? Well, you can do that using a for all and a for any. Okay, so here's hello world. I want to check if this only has capital letters. So I can do something like all, check that it's every member of this list has to be true. And what I want to be true is I want to check X is a capital letter. I want to check that it's between A and Z for X in X's. Right? So it's saying this is true, that this is comprised only of capital letters. What happens if I put a space in here? What would this respond now? Is space a capital letter? So is everything in here a capital letter? No. That would have been useful too. I can say, well, I guess to know if there's a space in hello world, you just have to use subset, but they're very useful, right? So I can, this is going to allow you to write very compact if statements now using these for all and for any's, right? Because otherwise you would have had to use very many ands or a for loops, right? So do keep all and any in your pocket. That may actually be very useful for the assessment that you're currently doing. There's one more thing that you can do with list comprehensions, and that is you can filter across them. So if I want all the numbers less than 100 that are divisible by both 3 and 7, I can say, okay, take X for X in range 101. If X if not X divides 3 and not X divides 7. This is sort of like, this is kind of confusing, but this is the divisibility check. So a number is divisible by 3 if you divide it by 3 and get 0, which we have to convert to true with a not. Right, so this, I don't know. I don't like this nature of Python, but it is what it is. This is a divisibility test for 3, and this is a divisibility test for 7, right? So here you have your normal list comprehension with all the x's that you want to look at, and then you can just always add a condition for keeping or excluding, right? So this is going to go 0, 21, 42, 63, 84. So these are all the numbers less than 100 that are divisible both by 3 and 7. So this is also very, very useful. So the general pattern for a list comprehension is the following. You can say x for x and x's if px, and px is any predicate statement that evaluates to true or false. Or you can have x for x and x's for y and y's if pxy, or x for x and x's for y and y's for z and z's if pxyz. So you're not permitted multiple p's, but that doesn't matter because we have and, right? So you can always like enrich your P with very many ands if you want. So comprehensions are a way of rapidly forming lists and dictionaries that would otherwise require accumulation with a for loop. So what I'm going to do with the rest of class is I just have like a whole lecture of only examples. We're just going to code example after example after example, just so we can sort of get used to this notion of programming and utilizing all of the tools. Because I don't really have, the only tools I am going to be teaching you that we have left is a little bit of string processing. We're going to learn how to read from files next week, and then I'm going to give you some sort of general advice about debugging. But in terms of having the comprehensive set of tools required for doing all of computer science, you got it. Okay, so let's just practice. I think I have like 15 questions. So let's see. Write a function that capitalizes every character of a string. And I only want to utilize tools that we have. I don't want to Google how do I capitalize a letter, like, because I'm telling you we have sufficient tools for doing so. So we're going to have to think about this because we're going to have to build a bunch of tools in order to accomplish this. And we'll have to bring forth all of our knowledge of Python and strings and so on and so forth. Okay. So let's study the spec just to make sure that we understand everything. So this says, given C's, which is a string, I want you to capitalize every alphabet letter of that string. So if you have capitalized, boom goes the dynamite. It should capitalize every letter, but leave spaces and sort of non-alphanumeric characters alone. If you want to capitalize 1, 2, 3, sort of nothing happens. Okay. Let's think. What are the necessary components of this problem? What are we going to have to do in this problem? Yes. Okay, so we're going to have to check if a letter is capital or not. We know how to do that using a range. Okay, so that's sorted. So I can write that in if we want. Is capital. We'll just say x is a string, and this returns a bool. And I'll just return x is bigger than a and less than or equal to b. Okay, sure. What else do we need to solve this problem? Because that's how I program. I'm just programming being like, how would I solve this problem if I had a set of tools already available to me? And then I'll just go make those tools. So one of the tools I'm going to need here is capital. Okay, so maybe we do this. Let's just start writing. And this is a style of programming that I call wishful programming, where you just program and then you just type in functions that you want to exist and then sort it out later. Okay, so I want to do something like, okay, so we need to accumulate on a string. All right, so that's what I'm going to do. And then eventually I want to return that accumulator. What do I have to do in the interim? I have to say, okay, so for C in C's, we shouldn't check if it's a capital. Yeah, I don't need to check if something's a capital. I need to check if something is lower. It's capitals we just leave alone. Okay, lower. Okay, so for C in C's, oh yes, fine. For C in C's, if C's is lower, then we want to accumulate what? Yes. Okay, but higher up, right? Yeah, okay, so we know that C, the character we're holding, is a lowercase character. So what do I have to do to that lowercase character before I accumulate it? Convert it to an uppercase character. So I'll say like to uppercase. And I'll put that in. So this is why I'm calling this wish list programming. Like we're going to have to eventually then go and sort this out. Okay, so I'll just put that there. And it's something like 2 uppercase takes something like A and gives it A, but like 2 uppercase, something that's like a capital, it just leaves it as a capital. Okay, so for now, I'll just say return X's. It doesn't do anything, but we can keep going. Okay, so if it is lower, then I want to convert it to an uppercase character and accumulate. And else what? Else, well, I just accumulate. Okay, so first let's check if what I'm going to do here is I'm just going to replace this with X, right? Just so we can see what the effect of what we have done so far is. Sandbox. Okay, so let's see. Capitalize AABB. Aha. So we did manage to swap out the lowercase letters with X's. That's a good sign. Yes, sir? Implement CSS.upper then. Well, yes, like, look how many string methods there are. Like, of course, you're going to be able to find the method for doing the thing that you want to do in this list, but you're novice programmers, right? These are all of the sort of easy questions that we can ask you, right, before giving you much more complicated stuff. So if you're bypassing learning how to program by just calling a method, that's not programming. So be careful. Plus, it's a method. We haven't done objects yet, so of course it works. Don't get the impression that the things that I'm showing you in class are the only way or even the best way of doing anything. We have to go through, like, I can do everything that I've taught you in one line of Python coding, like every time. That wouldn't be very, very informative. But again, on an exam, a perfect exam question would be like, you used is upper on A1, implement it. How is upper implemented? Right, and it has to be implemented in Python, so let's do that now. But I'll just say, yeah, so we have is upper, something like that, dot upper. Yeah, but that begs the question, how did it do it? So let's just continue going. So imagine we don't have any of these methods, right? So how then is this implemented in Python? How did they do it? There's code, like there's code that's written that executes this. What is that code? Right, and let's program it here. Given that, right, how do I convert a lowercase character to an uppercase character? Okay, so here let's have a precondition. Now this is important. This is important because we have the tools necessary to solve this problem. And this is the whole difficulty of programming. We have to be creative in the way that we exploit the things that we've already been given. Right, to solve the problem. It's creating things with a limited set of tools by creating a more enriched source of tools. So let's say this precondition is that X is guaranteed to be lowercase, right? Because we've checked it. Okay, so by the time it goes to uppercase here, we know that it's lowercase. But how can I convert a lowercase character to an uppercase character? And let's just go through all the tools that we have. What do we know about strings? Yes. Okay, so we know that every string has an ordinal, right? It designates its place in the ASCII or Unicode tables. We also know that we can take these numbers and revert them, right? So I can go from letter to number and number to letter. Can I utilize this for converting something to an uppercase letter? How? Yes.
What you do is, so as you just said, they each have values, right? So the computer doesn't really know what's capital or not. So writing all of the alphabet wouldn't be logical, right? And so if you look at, Unicode 8, for instance, so it starts from 0 to 9. And then from there, it's the alphabet in capital, if I'm not mistaken, and then the rest, right?
Yeah, so, I agree. But what's the answer?
Yeah.
Yeah.
The answer is you have to check every digit for the value, and then transfer that value from one to another.
Okay, so I think what you're saying is that we just have to take a number, like take the character, convert it to a number, shift that number by some value, and then convert it back. Yes? Okay, let's do that. Okay. So I know that A is the 97th character. I can also know that the order of capital A is 65. So how do I convert lowercase a to capital A? Well, how much does uppercase a and lowercase a differ by in the Unicode table? Okay, so, okay, look at this. If I take, okay, so I want to convert back to a character, the number, okay, so tell me what A is ordered in the alphabet and convert that to a character. If I'm going to add 1, that's going to give me a B. But I'm telling you, I can add, or we could subtract and get that. So what do I have to subtract or add by to go from A to lowercase a? Huh? Yeah. Subtract 30. Why 32? Is it? Oh, okay. Oh, great. Okay, yeah. So I was, that's better. I was just going to say this, ord A, minus ord A. I think that's the right way around. Oh, no, sorry. Right? So that's the distance between lowercase a and uppercase a. So that's like how much I have to shift by. But like that's the same distance for all of them. Like it's not going to work for anything that's not an lowercase character, but we have that as a precondition, so that doesn't matter. Okay, so what I need to do here is just this effectively. Oh, that was the wrong one. This one. Okay, so convert to a character the number, which is the conversion of the input to its ordinal, shifted by the distance between capital A and lowercase a. And let's see what we have here. Okay, to uppercase E, to uppercase A. All right, let's so that seems to be working. Is there anything left then to implement for our capitalized routine? No? Okay, let's see if that works then. Capitalize. Boom goes the dynamite. Whoops. There you go. It works. It works. And we did it all from scratch using the tools that were at our disposal. Right? So this is how they implemented that method. Right? So you should always ask yourself whenever you're utilizing something, well, this is written in Python. So how exactly was it done? Maybe I'll leave this one for you to do at home. If we have time, I'll come back to it. But because now I've given you list comprehensions, this should be quite. Some of you are taking linear algebra. It doesn't really matter. Put a box of numbers, put a bunch of numbers in a box, and just permute their rows and columns. Right. So you see that this has row 1, 2, 3, and row 4, 5, 6, and row 7, 8, 9. And for this one, this has a column 1, 2, 3, column 4, 5, 6, and column 7, 8, 9. So if something has the position sort of 0, if something is at position 2, 3, in its transpose position is 3, 2. So you just have to flip all of the columns and the rows. We'll come back to this if I have some time. I think I have more interesting ones than this. Caesar cipher, maybe you should do this one at home as well, because it's the same notion of sort of like shifting these letters around. Let me see if I can, what function would I think is, write a function that when given a string, returns a dictionary whose keys are characters and whose values are the positions of those characters in the string. This is a good one because we're going to get to use our enumerate function. So does everyone understand the spec definition here? Right, so you have this string, and there's a at index 0, small a at index 0, small a at index 1, big A at index 2, big A at index 3, small b at index 4, small b at index 5, big B index 6, and big B index 7. So let's see if we can code this up. Okay. All right, all of the wrong quotes. All right, any ideas for this one? So it's like, again, we're just going to have to do an accumulation. A lot of the problems that we'll be giving you are effectively fall into this category. So let's build a accumulator dictionary. I'll call that D. I'll return it eventually. And now what I want to do is I want to walk through X's, but I need to know what X is. I want to walk through X's, but with indexes. So what is the tool that we have for this? Yeah. No, I'd like to do it the way that I like that goes through our learning objectives. But do you have do you have a clever one-line solution or something like that? Are you using an enumerate? Okay, great. That's what I so I'll accept this as being your solution because it's probably something the same. Yeah, yeah. Yeah, that's exactly what I'm going to do. Okay, so remember this enumeration is going to let us walk through the elements of X's, but with also with the index. But we got to be careful, right? Because we don't want to key into this dictionary unnecessarily, because that's going to throw an error. So I actually, yeah, let's. I said that one thing that we can actually do is just assign default values here, which will save us an if statement. So why don't we just do that? So I'll just say, okay, go through your, so take X for X in X's. Those are all of the characters. I'm just going to say, give this a default value of empty list. Okay? Because that's the thing that all of these accumulators are going to have to start from. Okay, so I've just said, look, just go through it all and assign everything to empty list. I'll just put a pass here. And if we can print this D just to see what's in it, you'll see duplicates aren't going to be there. So character index of this. Oh, that printed twice because of that. But you see, A is only in there once. Capital A is only in there once. Capital B is only in there once. It's not going to add duplicate keys. Right. So the second time it said add this key to the dictionary, it's like, oh, it's already there. There's nothing really to do. Okay, so we have default values. So now this should be really easy. So I'm going to walk through this through my input string, X is, and I know what the character is, and I know what its index is. So I just say this dictionary at this key, maybe I can even, wait. Yes, this dictionary at that X, right, at this character, I want to append to that list the index that list is at. So let's see if that works. Take that print out. Well, I'll leave that print in. We'll see how it changes. Okay, so there is the default dictionary that was like spun up at line 11. And then I'm just walking through this list with an enumerate and just appending the list positions there. So 0 and 1, 2 and 3, 4 and 5. So don't worry that this and that are out of order because dictionaries don't have order, right? It's just, that's why we use the set braces. Yes, sir. What do you mean? I wouldn't, because A, that may change in the future. And yeah, I just if because we would never string test against something that's unordered. Like you don't treat something that's unordered as ordered because it has some weird Python nuance. I've worked at companies where we've done that and the nuance has changed and it broke everything, right? And they said, why would you ever do this on an unordered type? That's your fault. It was our fault. Okay, what else do we got here? Write a function that merges two dictionaries. So I'm going to give you two dictionaries, and they may have similar keys. So I would then want to take their keys and go to like a list of their values, right? So if I give you a dictionary 1 that goes to the list 2, 4 that goes to the list 5, 6, and another dictionary that takes 4 and goes to list, oh, gee, what am I doing here? We're in a dictionary where each key is a key that is both, oh, this is not really combined. This is more like intersect. Okay, so I'm going to call this intersect. So really what we need to do in this one is I'm going to give you two dictionaries, and I want you to take the value associated with each key in the new dictionary is the sum of all the integers associated with the key that in D1 and D2. Okay, this is just a bad name. I'll just call this foo. But what we need to do is find keys from both dictionaries that are equivalent. And then in our new dictionary, I want to map to the sum of that list. So let's take this and try to program it. Right. Oh, that's going to be bad. Okay, I'll just def, I'll say foo. And what are we taking? Okay. We're going to take a dictionary D1, which is a dictionary that maps integers to list of integers. And I'm also going to take another dictionary of that same type. And I'm going to return a dictionary which maps integers, oops, to integers. Okay. And the use case is somehow this. Okay, so we have two dictionaries. We need to find the keys that are common. And once we find the keys that are common, we need to put that into the new dictionary as the sum of the values that they're pointing to. So any ideas here? How can we do this? Okay, so we need a new dictionary. I'll call it D3. That's going to be our answer. I'll call this a dictionary and I'll return the dictionary. Now, I'm not looking for like comprehensively the whole answer. I'm just looking for like how, like I want to go through the thought process of how we're solving this, right? So how do we need to treat this? Like, what are we doing? Right. So like what tools are at our disposal and which one should we use? Okay, so what's the first problem that we have to work with? We need to find all the keys of D1 that are also keys of D2. Is that something that we're absolutely going to have to do? So how can we isolate a key of D1 that is also a key of D2? That's a great idea. So let's for loop. So for key in D1. Okay, so remember, for loops over dictionaries are going to iterate through the keys of the dictionary. Okay, so I'm looking at every key of D1 in turn. How do I determine if that key is also a key of D2? You want to, and then that would work. Is there a better way? Yeah. Yes. If key is in D2. Yes. So you could, but that would have worked, and probably in is implemented that way. But just use in, right? You can always ask if something is in an iterable. Okay, so if key's in D2, then what? Oh, key is both in D1 and D2. Okay, so we've isolated a key that exists in both. What should we do with it? What is the objective? I need to return a new dictionary whose key value pairs are keys that are both in D1 and D2. Okay, so at this point, I know I want to put this key in D3. But what's going into there? Well, it should be the sum of whatever D1 is mapping to, whatever list D1 maps to, plus the sum of whatever D2 is mapping to. So let's see if this is working. Whoops. Oh, I called it foo. I should call this foo as well. Or 19. Any questions about that? Right, so it's like all of these questions with for loops are effectively the same. You're for looping through some structure, and then you have some type of this statement for processing it. Okay, let's try more. Write a function with the following contract that does a reverse lookup. So I'm going to give you a dictionary, and I want you to return to me all keys that correspond to some value. Right, so this is called the reverse lookup in a dictionary, right? So if I give you like 1 goes to Bluey, 19 goes to Chili, minus 31 goes to Bluey. If I reverse look up Bluey, you should get back minus 31 and 1. So let's try this one. Ah, the bad quotes again. All right, I'm gonna do this the clever way. All right. Okay, everyone understand the sort of the spec? Okay, so what do we do now? So what are so this is the value that we're trying to reverse look up. This is the dictionary that we're going to be looking through. How come I can't give item a type hint here? Yeah. It could be anything, right? We could put anything that you want can be a value in a dictionary. So I can't type it, hint this. I can't really specify what the keys of D is either, because it could be anything immutable, right? So this is an appropriate type hint, or this is as much information as we possibly can give. Okay, so what should we do now? So what do we need to do? What are the things that we need to look at here? Yes. Well, I'm sort of, we need to check every value, I guess, right? If I'm like doing reverse lookup on a value, I need to look at all the values of the dictionary. How do I look at all the values of a dictionary? Well, I can say for key in this dictionary D, then the value is what? D at key. Okay, so I'm like, I can very trivially hold the value of stuff in here. Okay, so I'm going through this list, I'm holding values, and what do I need to eventually return? Well, I have to eventually return a list, right? So I should accumulate on some list and eventually return that. Okay, so like what goes in this list? Well, what's the purpose here? I'm going through this dictionary. I'm looking at all the values. And every time I find a value which matches the thing that I'm looking for, I have to record its key, right? Yeah, if the item that I'm searching for, actually, probably I should call this a value, not an item. If the value I'm looking for is equal to what D keys key to, then I can accumulate this, append that value. Let's see if that works. Okay, so I can do a reverse lookup. That gives us nothing. Do a reverse lookup on here. Oh, sorry, I'm putting not the values. That's a bug. I should be putting keys into here. All right, -1 and 31, right? Because again, I'm saying, okay, I need to I need to find all values that are equal to this thing that I am searching for. So like the philosophy here is like, okay, just look at all of the values using a for loop. And if the value is special, then do something with it using an if statement. But this is a very common pattern, having like an if statement inside of a for loop, right? You're always going to be processing, accumulating stuff like this. Write a function which inverts the keys and items of a dictionary. Since there may be many identical values, we will have to map those keys to lists, right? Okay, so here's a dictionary, right? That goes, that keys 1 to 10 and 2 to 10. And what I want to do is I just want to reverse all of these key value pairs. I want to make all values keys and all keys values. However, what's the problem here, right? I can't, can I just go into this dictionary and flip all keys and values? No, because in a dictionary, the keys have to be unique, but there's no uniqueness guarantee on the values, right? So here I've already shown you, here's a dictionary with unique keys with values that are identical, right? So we can't, it's like function inversion. Not every function has an inverse, right? So we can't, it's not as trivial to invert this dictionary as it may seem, because we're going to have to go from, so if this was type A and that's type B, this dictionary is going to key type B to lists of type A, right? Because there may be many keys which have mapped to the same value, right? So that's why we have to collect them with lists. Okay, so let's do this one. And then maybe we can go back to the transpose, or I can let you go. Okay, return the inverted version of D. Okay, so we need an accumulation. We need to have an empty dictionary, and eventually we need to return that dictionary. So I need to now look at every member of this dictionary. So again, I was going to say for key in this dictionary, we can have its value if we want. That's this. But what am I trying to do here? Well, okay, so I found a new value. That's this, D at key. Okay, so the values now need to become members of this dictionary. So that should be equal to, like, I need to append to this. I have to do this more wisely. So suppose it's the first time that we see this value. Okay, then I need to say, okay, check if my value is in the answer. If value is already a key in the accumulator, then there's already something there living. So I can say accumulator at value, please append this key. Okay. But otherwise, you're the first thing going in. So I have to say accumulator at value, you're going to be equal to this, just the singleton list. This is what you have to do. This if statement is required if you do not have default values set. So let's see if this will work. We can invert this dictionary. You get 10. Okay, so let's see if we can enrich this more. So I want to go from 3 to 7 and maybe from 7 to 3. Okay, let's put more things to 3. I also want to take 8 to 3 and 9 to 3. And there you go. It seems to be working. So we've inverted this. Okay, so what else do I have? Okay, let's go back. Maybe then we'll just try to talk about the transpose problem, because this is always like a list indexing disaster. But if we use our list comprehensions, I think we can solve this problem pretty compactly. So let's give it a go, and then I'll let you guys go. So these are the old list hints. They used to have to be capitals. They've already changed. Okay, so let's just give us a usage example. It's going to be a little bit more tough. Okay, my usage example is transpose of 1, 2, 3, 4, 5, 6, 7, 8, 9. That should be equal to this new list, which has just permuted the rows and the columns. So we're going to get 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we don't assume that this is a 3 by 3 matrix. We assume that this is sort of like square, that it has as many columns as it has rows. Now, how can I do this? Okay, so we're going to have an answer, which is going to be a list, but actually it's going to be a list of lists. Okay, so if I for loop through AS, what am I getting? So I'll say, yes. Yeah, so we're passing in a list of lists. So the things that we're iterating through are going to be lists. So I think that bears repeating, right? So if I have a list, like 1, 2, 3, 4, 5, 6, if you iterate through that list, you are in fact, you're getting lists themselves. So if you have the funky thing that can happen when you have list of lists, which is why I have this naming convention, is you can actually for loop through them twice. So pull out a list from X's before, and then pull out X's from X's. Right? And you'll see actually that we're going to touch each member of those lists in turn, right? Because like you could enumerate, you could iterate through something whose members are iterable. Right. So just keep that in mind. Like you can, if you pull out a list, you can also for loop through the individual parts of that list. So I'm going to say for a row in A's, I pulled out a row. Well, actually, how should we do this? This is a little bit tough. Like, so how can I form, I need to form a new matrix, which is going to be a list of rows. So basically what I want to do is build the new rows. But what is in each row? It's like, look, we have to look back here, right? So I need to build this, then that list, and then that list, right? So I need to build the list 1, 4, 7 and append it to the solution, and then append the list 2, 5, 8, and then append the list 3, 6, 9, and then we're finished. But the question is, how do I get 1, 4, 7? Yes. Right, so we can do something like this. Okay, I'm going to take. Okay, so I have this as my matrix. Okay, so, whoops. There's a matrix. Okay, it's a list of rows. So what I can do actually is build a list comprehension and say, okay, so take a row for row in X's. That's that. But I could also say take a row out of X's and look at its 0th component. What did I just generate? That's the first, that's this. Okay, because I said grab me this, grab me this, grab me that, and grab me that. Okay, so what happens if I change this to a 2? Okay, so what happens actually if I change that to a 3? Oh, sorry. I should have started. I missed the 1. Okay, so I can clearly now generate new rows. Okay, so I'll just do one more thing. But I want to do this for what? I want to do this for every row or for every column. So I want to put that into a new list comprehension actually and say 4K in range length of x's. Right, and this is going to work for the arbitrary cases. So I'm going to just throw that into here. This is why I think these list comprehensions are so useful. Okay, so I'm going to do that there. Can we transpose this? Ooh, oh, did I mean a? I'll just change that to x's. I transpose that? Sure can. Let's add more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Matrix transpose in one line. Okay, so just go study these things. Do use the help center. It's sort of underutilized. Do prepare for your midterm. And I'll see you next week for your last lecture with me before we hand off to the object-oriented programmer teacher. See you guys later. Bye, guys.